In this video, we will be solving oblique triangles, meaning non-right triangles, using the law of sines and the law of cosines. But how do we know whether to use the law of sines or the law of cosines? Well, that's going to depend on the type of information that we're given. If we're given angle, side, angle, angle, side, or side, side, angle, that's when we do the law of the law of sines. If we are given side, angle, side, or side, side, side information, then we do the law of cosines. Keep in mind that side, side, angle is the ambiguous case. So we will do the law of sines, but we have to be careful because there might be two triangles, or there could be one triangle, or there could be no solution. Okay, so take a look at problem number 1. Let's draw ourselves a diagram so we can see what's going on. We have two angles and a side. So right away, I know this is going to be, the only types that have two angles and a side are angle, side, angle, or angle, angle, side. So we will definitely be doing the law of sines for this problem, and it definitely will not be the ambiguous case. So we don't really have to worry about how we draw the triangle since there's no ambiguous case to worry about. All right, so it doesn't have to be any special way. So this is triangle ABC. Angle B is 70 degrees. Angle C is 58. And side A is 84. So that goes right here. So this is an angle, side, angle situation. So we will definitely do the law of sines. Okay, but before we do that, let's go ahead and write our solution box for the missing stuff. So we're going to need to find the measure of angle A, because that's not given. And we will need to find side B. And we will need to find side C. Once we find these three quantities, we will have solved the triangle. Okay. So first, we can easily find angle A by subtracting these two from 180. So let's go ahead and do that. Great, so I got 52 degrees for that. Now, let's go ahead and find side B using the law of sines. Okay, so we can definitely use this pair of angle and opposite side. Since I'm solving for side, I'm going to put my sides in the top. So I'm going to say 84 over the sine of 52. And that's going to equal side B over the sine of 70. Okay, so to solve this, I need to multiply both sides by sine 70. Okay, so I can just do sine 70 on both sides. All right, that way these will cancel out and I get B by itself. So go ahead and put this entire expression in your calculator now. So I'm getting 100.169. So now let's do the same thing again, but let's go ahead and find side C. So again, I'm just going to do 84 over sine 52 is equal to side C over the sine of 58, which is angle C. All right, so this is just going to be the exact same thing as before. I will multiply both sides by sine 58 because that will get C by itself. So go ahead and put this entire expression in your calculator, and that should give you side C. So I'm getting 90.400 for that. So there we have solved triangle number 1. Triangle number 2 is pretty much the same thing. I have two angles and a side. So I know this is going to be law of sines, and I know this is not going to be the ambiguous case. So it really doesn't matter how I draw the triangle, because I know it's going to form a triangle, and I know it's going to form only one triangle. So I'll just say ABC like this, and then angle B, we're told, is 99. You know what? I'm seeing that that is an obtuse angle, so I would recommend that if once you notice that something is an obtuse angle, go ahead and just draw it as an obtuse angle. Sometimes it doesn't make a difference, but why take the chance? Okay, so here we go again with that modification. So angle B is 99, so I just went ahead and made that obtuse. Angle C is 53. Angle A is unknown. Now side C is 29.4, so that's going to go right here. So let's go ahead and set up our solution box. So we're going to need the measure of angle A for this one. And we're going to need side A and side B. All right, once we find these three quantities, we will have solved the triangle. Now, we're given two angles, so we can easily find the third angle by subtracting these from 180. So I'm getting 28 degrees there. So let's see if we can find side A next. So using the law of sines, since I'm looking for a side, I'm going to put my sides in the top. So I'm going to start off with 29.4. All right, that's my side over the sine of the opposite angle. All right, so over the sine of 53. And I'm looking for side A, so I'm going to say side A over, well, this is side A, over the sine of angle A, so the sine of 28. Okay, so to get A by itself, I need to multiply both sides by sine 28. So these will cancel each other out. That leaves A by itself. Go ahead and put this whole expression in your calculator at once. So I'm getting 17.283 here. Let's go ahead and do the same thing to find side B. So once again, I'm going to set up my law of sines with sides in the top since I'm looking for a side. So 29.4 over sine 53 again. All right, but this time I'm looking for side B. Okay, so I'm going to say sine of 99. So to get B by itself, I need to multiply both sides by sine 99. That way these will cancel each other out, leaving B by itself. Go ahead and put this expression in your calculator all at once. I'm getting 36.360. And there we have solved triangle number 2. Looking at problem number 3, I see that we have two sides and an angle. This could be the ambiguous case, so I'm going to be very careful the way I set this up. I am going to definitely start by drawing a horizontal segment. I'm going to put an angle on the left side like this. I'm going to put my one angle right here, so that's going to be my 57. For now, I'm going to make this a dotted line. If this is the ambiguous case, this will be my swing side, and as opposed to my rigid side. If this is angle A, then that makes this side A, so my swing side will be 12. I'm going to make the other side my rigid side, so I'm going to, well, I should label these. So this is A. I'm going to make the other side my rigid side, so I'm going to put the 19 here. So if this is side C, that makes this angle C, which means that this would be angle B. All right, I notice that this is side-side angle. So this is the ambiguous case, so I need to worry about whether or not this even forms a triangle at all. And if so, does it form one triangle or two? So the first thing I need to do is figure out if it forms a triangle at all. Okay, so to figure that out, I'm going to think about the height of this triangle, all right? What's the height of this thing? So this is going to be the sine of 57, all right? So I'm going to say the sine of 57 is equal to opposite over hypotenuse. So that should be h over 19. So that means 19 times the sine of 57 is equal to the hypotenuse. So I'm putting this in my calculator. So 19 sine 57. All right, I'm getting 15.935 is equal to the height. So if this is 15.9 and the swing side, the rope, is 12, all right, is this rope going to reach the other side? The answer is, of course, no, it will not. Okay, so think about it. This is the swing side, and we're supposed to imagine it swinging back and forth, but the rope is only a length of 12. So even if we put it straight down, it wouldn't reach the ground. So we'll stop here and simply say no solution. All right, looking at number 4, I see that we are given 3 sides. And when we have a side-side-side situation, this is when we use the law of cosines. There is no ambiguous case, so I don't have to worry about that. So here's a picture, just for fun, though we won't really need it. So apparently we have angles T, U, and V. So side T is 5.2, side U is 4.1, and side V is 8.6. All right, so of course the 3 things that we need to find are the measure of angle T, the measure of angle U, and the measure of angle V. Once we find these 3 angles, we will have solved the triangle. So we're going to use the law of cosines. So let's start by finding the measure of angle T. So since we're finding the measure of angle T, I'm going to start my law of cosines with T squared. All right, so T squared will equal U squared plus V squared minus 2UV cosine of angle T. All right, so I'm just going to substitute these 3 values in. So I've got 5.2 squared is equal to 4.1 squared plus 8.6 squared minus 2 times 4.1 times 8.6 cosine of angle T. So I need to get cosine T by itself. I will start by subtracting these 2 terms from both sides. So that's going to give me 5.2 squared minus 4.1 squared minus 8.6 squared. All right, once these are gone, I still need to divide by everything in front of cosine T. So I need to divide all of this by the negative 2 times 4.1 times 8.6. All right, and this should give me cosine of angle T. But I don't want the cosine of T, I want angle T itself. So in order to find angle T, I need to do the inverse cosine of all of this. And if I do that, that will give me the measure of angle T. So go ahead and put this entire expression in your calculator all at once. So I am getting 25.349 degrees. Now let's do the exact same thing to find the measure of angle U. So since I'm looking for the measure of angle U, I'm going to start off my law of cosine with U squared. So u squared will equal to t squared plus v squared minus 2tv cosine of angle u. That's my law of cosines. So I'm just going to substitute in all of these values, which I do have. Okay, so u squared, so that's 4.1 squared is equal to 5.2 squared plus 8.6 squared minus 2 times 5.2 times 8.6 cosine of angle u. So to get cosine u by itself, I need to subtract these two terms from both sides. That's going to give me 4.1 squared minus 5.2 squared minus 8.6 squared. All right, that gets rid of these, but to get rid of this part in the front, I need to divide by everything in the front of cosine u. So that's why I'm going to put all of this in the denominator, negative 2 times 5.2 times 8.6. All right, that's going to get the cosine of angle u by itself. But what I really want is angle u instead of the cosine of angle u. So if I want angle u by itself, I need to do the inverse cosine of all of this. That will give me angle u. All right, so go ahead and put this entire expression in your calculator all at once. I'm getting 19.729 degrees for angle u. Now to find angle v, I can just subtract these two angles from 180. And I'm getting 134.922 degrees. And there we have solved triangle number 4. All right, looking at number 5, I see that I have two sides and an angle. This could be the ambiguous case, so I'm going to be very careful about how I draw my triangle. I'm going to start by drawing a horizontal segment. I'm going to put my angle on the left-hand side like this. I'm going to make one side on the right dotted. If this is the ambiguous case, this will be my swing side. I will treat it like a rope. I'll put the one angle that I'm given right here, 38.7 degrees. So that means this has to be angle B. They give us side B, so this is 172. Now they give us another side. I'm going to make that my rigid side, so I'm going to put 203 right here. Now if this is side C, that means across from it must be angle C, which means this must be angle A up here. Now this is side-side angle, so this is the ambiguous case. So I have to worry about, will there be one triangle, will there be two triangles, or will there be no triangles? So let's start by figuring out if this will make a triangle at all. So we can figure that out by looking at the height. All right, so this would be the height of the triangle. We can calculate the height by doing the sine function. So I'm going to do the sine of 38.7. All right, that should equal opposite over hypotenuse. So that should equal h over 203. Multiplying both sides by 203 is going to give me 203 sine 38.7 is equal to the height. Punch this in your calculator real quick. So 203 sine 38.7. I'm getting 126.924 is equal to my height. So if this is 126 point something and my rope is 172, that's definitely going to reach. So I will definitely have at least one triangle. So there will be a solution. So now the question becomes, will there be just this one solution, or will there be two solutions? Okay, well, it turns out there will be two solutions, because you can form a second solution if this rope can swing inside the triangle like this and still fit. So imagine that I swung my rope like this. So now my 172 would be here. The question is, does this fit? Yes, it does, because the rope is shorter than the rigid side here. So it fits underneath here. If this was, let's say, 210, then it would stretch outside because it would be longer than the rigid side. But as long as this is shorter than the rigid side, it'll fit. So this rope will fit in both of these positions, so it'll make two different triangles. Now, what I would do if I were you is I would draw these two triangles separately. Okay, so let's see, I'm just going to erase this to make room. So I'm going to draw this triangle formed by the rope in the pink position. I'm going to draw it right here. So it would look like this. Okay, so far I've drawn this portion. Now I'm going to draw the rope, okay, which is going sort of like this. All right, and now I'm going to draw this rigid side like this. Okay, so this angle B is still right here, and it is still 38.7. Angle A is up here, but I really can't call it angle A because it's different. All right, this was a wider angle, so I'm going to call this A2. All right, angle C is here, but again, this is not the same as the blue angle C, so I'm going to call it C2. Okay, now this rigid side is still 203, and the swing side is the same rope. It's still 172. Okay, so these are the two triangles. I'm just going to go ahead and erase this and just deal with the one triangle at a time. So drawing my solution boxes. For this triangle, we need to find angle A, angle C, and side A. And in fact, I'm going to, just like I called this angle 2 and, A2 and C2, I'm going to call this A1 and C1. So we're going to need to find the measure of angle A1. We're going to need to find the measure of angle C1. And we're going to need to find side A, A1. So once we find these three values, we will have solved the blue triangle, triangle number 1. And similarly, for the red triangle, we will need to find the measure of angle A2 and the measure of angle C2 and side A2. So once we find these three quantities, we will have solved the red triangle. Okay, so we're going to solve these using the law of sines. Okay, so let's start with the blue triangle. We have this angle and opposite side pair. So this is where we will begin. Okay, so looking ahead, I see the 203 is across from angle C. So that's the next thing we're going to be able to find. So I am going to target angle C1. So since I'm looking for an angle, when I set up the law of sines, I'm going to put my angles in the top. So I'm going to have the sine of 38.7 over 172. equals. All right, so, and here I will have the sine of C1 over 203. Now, to get C1 by itself, to get the sine of C1 by itself, I need to multiply both sides by 203. So I'm going to do that. Okay, so that's going to give me the sine of C1. Now, to get actual angle C1, I'm going to need to do the inverse sine of all of this. So what I really need to do is the inverse sine you know what, I think I'll better rewrite it. So I'm gonna have to do the inverse sine of 203 sine 38.7 over 172. And that should give me the measure of angle C1. So go ahead and put this whole thing in your calculator all at once, and that'll give you angle C1. So I'm getting 47.556 degrees. Now we can easily find the measure of angle A by subtracting these two angles from 180. So I am getting 93.744 degrees for the measure of angle A. So finally I need to find side A. And once again I am going to use the law of sines. But this time, because I'm looking for a side, I'm going to put sides in the top. So I'm going to put 172 in the top this time. So 172 over the sine of 38.7 is equal to, now I'm looking for side A1, so I'm going to say A1 over the sine of angle A1, which is 93.744. So in order to get A1 by itself, I need to multiply both sides by sine of 93.744. Okay, that way these will cancel out. So that will leave A1 by itself. So go ahead and put this entire expression in your calculator all at once. So I'm getting 274.506. Now let's turn our attention to the red triangle. The first thing we need to do is look at this angle that is created by the swing side. With the swing side in the blue position, angle C is 47.556 degrees. It's an acute angle. But if we swing that angle inward, we get angle C2. So it goes from being an acute angle to an obtuse angle on the inward swing. These angles will always be supplementary. So if I want to find angle C2, I need to take angle C1 and subtract from 180. So I'm getting 132.444. Again, that was 180 minus 47.556. That's how I found this angle. Now we can easily find angle A2 by subtracting these two angles from 180. And I'm getting 8.856 degrees for angle A. So that just leaves us to find the length of side A2. So I will use the law of sines, and I'm going to make sure to put sides in the top since I'm looking for a side. So this is going to be 172 in the top over the sine of 38.7. And that's going to equal side A2 over the sine of angle A. All right, the sine of 8.856. All right, so basically we have to cancel this out, and you put this whole expression in your calculator at once, and I'm getting 42.351. So we will just do one more problem on this video. Again, I see that we have two sides and an angle. So at a glance, I'm worried that it might be side-side angle. Now, I've learned how to tell that this is not going to be side-side angle because when it's side-side angle, you always have an angle and then its opposite side. So I see that the angle is angle A, but there is no side A. So this will not be the ambiguous case. But if you did not notice that, or if you didn't understand what I just said, you could treat it like the ambiguous case until you finish drawing the triangle. So say you thought this might be the ambiguous case because you see two sides and an angle. You would make a horizontal segment as the bottom of a triangle. You would put in an angle on the left-hand side like this. All right, you would put the one angle they gave you right here in the left, and so that would make this angle A. Now you would probably make this a dotted line just in case this is a swing side. Then we have these two sides that are given. Now, neither of these sides is the side that is across from angle A, because neither of these is side A. So that means we are not given the swing side. We're not given the rope. That means these other two sides must be these two sides over here. So it doesn't really matter which one you pick to be which. I'll put the 40 here. That makes this angle B. I'll put the 45 here. That makes this angle C. Either way, you see that this is a side angle side situation. All right, side angle side. So this is not the ambiguous case. Not only is it not the ambiguous case, but for side angle side, this is one of the times when we do the law of cosine. So we will not be doing the law of sines on this particular problem. So there's no need for this to be dotted then. All right, so I'm just going to go ahead and make this solid. Let's think about the three pieces of information that I need to find. I am going to need to find the measure of angle B, the measure of angle C, and the length of side A. All right, once I find these three pieces of information, I will have solved the triangle. Let's see. Let's start by using the angle that they gave us. So I'm going to start by finding side A. That's why I'm going to start off using the version of the law of cosines that begins A squared. All right, A squared is equal to B squared plus C squared minus 2BC cosine of angle A. Okay, so A squared is equal to 40 squared plus 45 squared minus 2 times 40 times 45 cosine of 51. All right, but we want A by itself. So what I need to do is I need to take the square root to get A by itself. I'll have to take the square root of both sides. So this is what I'm going to put in my calculator, this entire expression, including the radical sign. All right, I got 36.871. So now I'm going to go back and find the measure of angle B. So since I want the measure of angle B, I'm going to start out with the version of the formula that goes B squared. So B squared is equal to A squared plus C squared minus 2AC cosine of angle B. Okay, so that means I'm going to have 40 squared right here is equal to A squared, so I'm doing 36.871 squared plus C squared, so that's 45 squared, minus 2 times 36.871 times 45. Cosine of angle B. All right, so if I want to get cosine B by itself, I need to start by subtracting these two terms from both sides. So that is going to give me 40 squared, all right, that's this, minus 36.871 squared minus 45 squared. Now I've subtracted these two from both sides. That still leaves this part in the front. I need to divide by all of this to get cosine B by itself. So that's why this is going to be all over negative 2 times 36.871 times 45. All right, so that is going to equal cosine of angle B. But I really want angle B by itself, not the cosine of angle B. So if I want angle B, then what I really need to do is do the inverse cosine of all of this, and then that will give me the measure of angle B. So go ahead and put this whole thing in your calculator all at once. So I got 57.469 degrees for the measure of angle B. Now we can easily find the measure of angle C by subtracting these two angles from 180. So I got 71.531 degrees. Alright, that's going to do it for this video. I hope it was helpful. I look forward to seeing you on the next video.